It's thousands of years ago, and the earth starts shaking beneath your feet. No modern tech, yet buildings stand tall. How did they do it? Ancient architects had secrets, brilliant techniques that made their structures nearly earthquake-proof. And guess what? Many still stand today. Let's uncover this architectural wizardry. Let's talk about Japanese pagodas, the stunning multi-tiered towers you've probably seen in pictures of Kyoto. What's incredible is that these ancient structures have survived earthquakes for centuries. How? The secret lies in something called the Shinbashira. Think of it as the spine of the pagoda, a central wooden pillar that runs straight through the middle. Now, here's the twist. This pillar doesn't actually support the building's weight. Instead, it works like a shock absorber. When the ground shakes, the pagoda's multiple layers sway independently, and the Shinbashira absorbs and redistributes the energy, reducing the impact. It's kind of like a giant spring holding everything together. What's even more fascinating is that the pagoda's design allows for remarkable flexibility. The tiers are built without being rigidly fixed, allowing them to move slightly during an earthquake instead of collapsing. This ingenious system has kept these wooden marvels standing for over 1,300 years, even in one of the most seismically active regions on Earth. So the next time you see one of these ancient masterpieces, remember, what looks like a symbol of serenity is actually a highly advanced piece of earthquake-resistant engineering. You know the Colosseum, the massive arena where gladiators once battled. It's been standing for nearly 2,000 years. That's through earthquakes, fires, even bombings. But how has it survived while so many other ancient structures crumbled? The secret lies in Roman engineering, specifically their revolutionary concrete. Unlike modern concrete, which can crack and erode, Roman concrete actually gets stronger over time. And the magic ingredient? Volcanic ash. When mixed with lime and seawater, it formed an ultra-durable material that could self-heal when exposed to moisture. That's right, Roman structures could actually repair themselves over time. But that's just part of the genius. Romans also mastered earthquake-resistant design by using arches. These weren't just for decoration. They absorbed and redirected seismic energy, preventing structures from collapsing. Instead of fighting nature, Roman buildings worked with it. And here's the wildest part. Modern scientists are still studying Roman concrete, trying to unlock its secrets for future buildings. So, while the Colosseum may be ancient, its engineering is still light years ahead of its time. The Great Wall of China, one of the most legendary structures on Earth. Stretching over 13,000 miles, it survived centuries of battles, brutal weather, and yes, earthquakes. But how? Well, here's the mind-blowing part. It's actually earthquake-resistant. Unlike modern concrete, which can crack under pressure, the wall's secret lies in its mortar. Instead of just using lime, ancient Chinese engineers mixed in a surprising ingredient: sticky rice. Sounds crazy, right? But this wasn't just any rice. The starch in the paste helped create a super strong yet slightly flexible bond. That meant when the ground shook, the wall didn't just crack, it absorbed the shock, shifting instead of shattering. And here's the kicker. Modern tests have shown that this rice mortar is stronger than some of today's cement. So, while the world has moved on to steel and reinforced concrete, the Great Wall stands as proof that sometimes ancient wisdom beats modern technology. Now, let's talk about the Incas, true masters of earthquake-proof architecture. Picture this: towering stone walls in Machu Picchu, standing strong against the test of time. No cement, no mortar, just massive stones cut with laser-like precision, fitting together like the ultimate 3D puzzle. And here's the mind-blowing part. Despite centuries of violent earthquakes, these walls haven't budged. How's that possible? The secret lies in their flexibility. Instead of resisting the earthquake's force, the stones move with it, shifting ever so slightly and then settling right back into place, like a well-choreographed dance. It's called ashlar masonry, a technique so advanced that even modern engineers are still trying to fully understand it. Some of these stones weigh over 100 tons, yet they fit together so perfectly that you couldn't even slide a piece of paper between them. Think about it. While modern skyscrapers need steel reinforcements and deep foundations, the Incas achieved earthquake resistance with nothing but raw stone and pure ingenuity. And the craziest part? We still don't fully know how they did it. Some say it was centuries of trial and error. Others believe they had techniques that have been lost to history. Either way, one thing's for sure. Incan architecture wasn't just strong, it was smart.